Ladies and gentlemen, please welcome to the stage Rayid Ghani, Distinguished Career Professor in Machine Learning at Carnegie Mellon University.
Thank you, and thanks for having me here. Excited to talk to all of you. What I've been talking about is using data and analytics, which again we all do, for having social impact in a fair and equitable way. So what I want to do is sort of start depressing all of you, right? Because if I start bringing everybody down, then there's only one way up, right? So let's do that. Let's talk about some depressing stories. So the first about is jail incarceration, and that's depressing. And the depressing numbers, if you look at the numbers, this is for the U.S. and just for jails. About 11 million people go through jails every year in the U.S. And yes, it costs a lot of money and all that stuff. But the depressing parts are the bottom three numbers. So 2/3 of people who go through jails suffer from mental illness, substance abuse, chronic health issues, and there's a lot of evidence that those are the underlying causes that actually have them cycle through jail. So they get out, they come back in, they get out. So this is some work we've been doing in Kansas in a county called Johnson County. And they have a high rate of jail reincarceration, people who cycle through the system. And so they came to us and said, look, we know we have a really high rate. We want to be able to reduce that. And one tool we think we have is mental health outreach programs. And what they wanted help with is to see how do we select, how do we prioritize people? They have limited resources to do this proactive outreach. How do we select people who can most benefit from it and will result in reducing their risk of recidivism? So what did we do? Well, we first combined a lot of data that we got from them from different systems, right? We got data from them from the criminal justice system, from their jail stays, how long they were there, why they were there, got data from the police when they arrested, what charges they were booked in. We got data from the mental health services team at the county that told us sort of their interactions with the mental health system, ambulance data, emergency room data, a lot of other things that we kind of integrated that together, as a lot of you do, right, in different projects, to then design a system, a machine learning system that would predict somebody's risk of coming back to jail. Now, it turned out that was accurate, but then the question if we should provide them with mental health outreach tools. So we started a randomized control trial a couple of years ago that every month would provide them with a list of people who are high risk of recidivism and have mental health needs, and they would then go off and connect with them through mental health outreach programs. And that's what the last 2 years. The results we're seeing now, some early results, that it's actually reducing recidivism risk for the people that they intervened on. And more importantly, they're also finding that the highest risk people are the ones that are being benefited the most. Because one of the questions was, who can we help? Who does this intervention help, and who does it not help? Because the ones it won't help, we then have to figure out how do we design new things, right? So we're seeing kind of really promising results by combining this data and machine learning, the randomized control trial. Right? So let's look at another example. And this is lead poisoning. So it's an issue in the U.S., an issue all over the world. And it's an issue because a lot of paint, pretty much in the U.S., every home built before 1977 has lead paint in there. And that's okay from inside the walls, right? But homes get old, paint starts chipping, kids start crawling, and as they crawl, they pick up lead dust and they put it in their mouth, and it goes into their bloodstream. And what ends up happening is the side effects on basically what happening is pretty horrible, right? IQ issues, learning disabilities, motor control issues, and the horrible, depressing thing is all of this is irreversible. Once somebody has been exposed to lead, there's really nothing you can do to prevent these things. So how do most governments deal with it today? Well, they wait until somebody gets lead poisoning. They test kids for lead in their blood, and if they find high levels of lead, then they go and look for problems in their house, and guess what? They find them because if they get lead poisoning. And so again, this was work with Chicago that we started doing several years ago, and they came to us with kind of a similar question of when we know we're being reactive, we could be proactive, but the problem is we only have limited resources to go find these problems and then fix these problems. So how do we prioritize the homes that we check? And so again, we took data about all the blood tests that they had done over the last 10 years, all the inspections they had done for every house over the last 10 years, all the data about the property, when it was rehab, when it was built, all the information, because that could tell us important things, combine all that together to predict when a kid is sort of turning, 2 months, 3 months old, can we predict if they're going to be high risk of lead poisoning in the next 6 to 9 months? Because they typically get that when they crawl. And if we could tell the health department when somebody is 2 or 3 months old, it gives them 6 months to then go and check in their home for lead issues. And if they are there, fix them before it becomes risky for the kid. So that system, again, ran a randomized trial, found it was effective at finding these problems before they became issues. And that's this in Chicago, also in hospital systems, to also work on pregnant women who are going for checkups. So the system will just raise an alert and say, hey, the kid that's going to be born will be high risk. So the health department has even more time to kind of plan what resources they need. Third example, also depressing, horribly depressing, is police misconduct. It's an issue in the US, it's an issue in other countries. And it turns out a lot of police departments in the US actually have these systems that they've built over the years called early intervention systems that are supposed to raise alerts when an officer is at risk of doing something horrible, shooting, injuries, other things. Except when they've built and installed these systems, they never bothered to evaluate them. So we started working on this a few years ago, and the first department we worked with is in North Carolina, in Charlotte-Mecklenburg. And the first thing we did was evaluate the system that they had deployed a few years back. We basically found that it was pretty much random. The idea was a good system should be able to detect who were going to do one of these horrible things, and also not have too many false positives, because it's not. It turns out it was flagging about half the police officers in the department, which made it totally unreliable and useless. So again, what we did was we took all the data that they had about the police officers, their training, their HR, combined that with the arrests that they were making, the dispatches they were sent on, and complaints against them, investigations, and put it all together to again build a system to predict which officers are going to be high risk of doing something like this in the next 6 months, 12 months, and then provide that information to the department, their supervised criminal affairs, to see to reduce that risk. Is it a stress situation? Is it a training situation? Is it putting them off duty for a while? A couple of indicators we found that put people at high risk were if they were repeatedly dispatched to suicide attempts or domestic abuse cases involving children, that made them temporarily high risk. And those are kind of stress indicators that you could put somebody off when they've been to one of those incidents. Don't send them another one for the next some period of time to reduce that risk. And so that system again is now deployed in a few different departments, and it's being used to sort of generate these alerts. Very different example. It's a little bit less depressing, but still pretty bad. Water pipes breaking, right? We've all probably experienced water pipes breaking, some more than others. This is some work we were doing in Syracuse, New York, which has, about 3 water breaks a year. And typically they're not fatal, right? Unlike a lot of other things we're talking about. But water pipes are expensive to fix because you have to dig up the street and it takes a long time. They affect people who live there because they don't get any water, and they affect stores who are selling fruits and any fresh produce or frozen things, because the water supply goes away and they can't sell those things, right? So it's inconvenient and it's expensive. So we worked with Syracuse to build a system for them that predicted which pipes were likely to break. And unlike some of the other examples, the idea here wasn't I predict this pipe is going to break so that they're going to dig up the street and fix it. The idea was that they could now coordinate with the roadworks department to figure out, okay, if a road was going to be repaired in 3 months, can they go a little bit deeper and kind of look at the pipe and replace the pipe? Or if the road wasn't scheduled to be replaced, or but it's still sort of medium or high risk. Can they put in a sensor, prioritize which places to put sensors in so that they can detect those breaks early and do something before it gets much worse? A last example I want to give, which is again a different example. This is work in Jakarta around at fatal traffic accidents. Right? The traffic there is bad, but what's really bad is that a few thousand people die every year because of traffic accidents. And the city there decided, we wanted to kind of figure out why those accidents were happening, what were the underlying root causes, so we could do something about them. And so, they put a bunch of cameras, they put a few thousand cameras in the city. And a couple of years later, they came to us and said, well, we have a few thousand cameras in the city that are collecting video 24 hours a day. And so now we have, thousands and thousands of hours of video. We don't know what to do with it. So they were not asking for us to build them a system that would, predict an accident or really anything around prediction, but they wanted to know, can you give us data that tells us what's happening, so that we can then look at it? And by data, they meant rows and columns, right? Not videos. That we can then correlate that with what happens in that area a few minutes later, a few hours later, what leads to accidents happening, so we could start causes. Right. So what they were looking for is really things like these types of events, like non-vehicles, right? So food cart vendors in the street, or pedestrians going in the middle of traffic, or motorcycles that are overloaded that are not balanced that might actually fall, or cars going the wrong direction. And so what we really needed to do was really figure out, what are the different objects that are, what direction they're moving in, where they're moving, so that we could sort of detect things like this, right? This is a two-way street. But you see cars coming around all the time. And what turns out that this could lead to sort of accidents happening, just down the street. And if they could detect these things, at least have this data, then they can start seeing, oh, maybe we need to put a median in the middle to stop people from crossing over. And that would reduce sort of the type of problems. So, stepping back a little bit, right? Like, what do all these projects that I talked about have in common, right? Well, there are many things, they're all about kind of some type of social issue or problem people deal with and trying to kind of tackle it. But one of the things they have in common is really that they all have data coming in from a lot of different places. And it's all being connected together, right? So if you take a look at the police example, it's coming from the HR system, the training system, the learning management system, the arrest system, the computer-aided dispatch, so the CAD system, the internal affairs investigation system, the complaint system, and it's all kind of being put together. And then we're building sort of these machine learning models to predict who's going to be at risk of doing something bad. And then we're trying to kind of prevent that from happening, right? So, but the first part is always the same with the lead poisoning. We're connecting all these things together about inspection and blood tests and what the house is and what the history is. And a lot of us work on that piece, right? So we a lot of our time is spent sort of basically doing data integration. And we also spend a lot of time sort of thinking about how to best do it, right? What database to use, where do we store it, what linkage tools to use, what queries do I run to make them more efficient? What are the ways to make these queries much faster, easier to write? We spend a lot of time thinking about that. But the question I want everybody to think about when we're working on it is, well, why are we doing it, right? Yes, we're doing record linkage, and yes, or data integration, and yes, we're using some tool that's really good at, efficient at storage and fast and querying and linking. But why are we doing all of that? We're not doing it because we want to integrate data. We're not doing it because we want to run SQL queries. We're doing it because we want to have impact, right? And in all these projects, the goal is impact. The goal isn't to build a machine learning model or an AI model, because who cares? The goal is to sort of prevent kids from getting lead poisoning, to prevent people from being subjected to police misconduct, to prevent fatal traffic accidents. And so it's impact on the people we're trying to support lives, and that's kind of what's not just motivating and driving all of this, but it's also what should be kind of in front of us when we think about this, right? That's kind of the thing that we should be thinking about. The second thing that they all have in common, or most have in common, is they all have these three pieces. One is we're sort of putting all this data together to understand what's going on, what's happened in the past. We're then using it to predict what will happen in the future, who's going to be getting lead poisoning or who might go back to jail. But then the third piece in all of these cases is we're trying to change that. We're trying to act and intervene and do something, right? And so in that case, it's really about that action that they're all supporting. Like we've all probably and problems, right, that are admired and looked at, but never taken any action on, or maps, right? So probably one of the more useless things that are built because you can't. Most people don't take actions with that, and actions are really critical, and quite frankly, like probably more critical than all the analytics. You need the other things. Right? Without doing all the integration, the prediction, everything, you can't take the action as effectively. So the other things are necessary, but they're not sufficient. It's the action that kind of makes the actual impact. So let's take an example. Let's say I asked all of you, if I use some of this to build the system to predict if somebody's going to commit a crime or not, is doing that good or bad? Right? Like some people might say, well, it's bad because what if you're wrong, and what if somebody goes and arrests them because the system predicted that they were going to commit a crime. Just because it happens in Minority Report doesn't mean it's actually a good thing, right? Somebody might say, well, it's good because you're trying to prevent crime and it's good for public safety. I would probably say it's neither good nor bad. At that level, it's an analysis that you do that's sitting on your computer. And if you don't take an action, nothing happens. And so in some ways, neither good nor bad. But the question is, if you use it to preemptively arrest somebody because you predict they'll commit a crime, well, that's pretty bad. But if you use it to sort of figure out, well, they actually have mental health needs and they need social service programs, I'm going to start providing them services so that they don't get into trouble and don't get to jail. But that's really good, right? So the analysis and the prediction and the machine learning is often neither good or bad. It's what you do with it, what you allow others to do with it. That's what's make things often good or bad. And those pieces are basically depends on your values, right? It's what you're building and how you're building it and what it can be used for is a matter of what your values are and the values the organization that's building it. And the system with tiny changes, 2 lines of code can be really, really good for the world, or really, really bad for the world. And so it's really important to think about what are the values I want to embed in the system. When I'm building the system, what should it be designed to do? And that's kind of what I want to sort of go a little bit deeper is, often when we have, when we're sort of doing things that are good, really wants to do good. I know most people don't want to do evil. And some people, might be exceptions, but we all want to do good. But just because we think we're doing good doesn't mean we're actually doing good, right? So, for example, you can sort of, if you build a system, so you're trying to build a system that, in the case of even, let's say, lead poisoning or the recidivism case in jail, let's say we're trying to build a system that an organization has limited resources, and they come to you and say, I'd like to build a system that can make the best use of the resources that I have. I have a very limited resource. I can only help 100 people a week. Can you help me figure out, the most people I can help with those resources? Well, if you build a system that's designed to be really, really efficient, which is to help the most number of people, you might only help people that are cheapest to help or easiest to help. And you might leave people behind who are more expensive or difficult to help. Right? So in one research, you can help 100 people who are really easy to help. In the other case, you might only have 20 people, but they really needed that help and wouldn't have survived without you. So the question really becomes, what are the values of this system? Is it efficiency? Or is it equity? And if it's equity, what does that actually mean? Who decides what those values are? Is it you or me who are building the system? Is it people who asked to build this system? Is it the people who the system is being used, or system who's being used by? Right? Those are things that we don't often think about too much. We often sort of say, give me your parameters, and I'll just put them in my code, and I'll run the code, and it'll produce things. Well, those producing things affect people's lives. So kind of, it's important to kind of think about, like, where are those parameters and values coming from, and how do we decide on them, and what is our role as people building these types of things? when this is happening, right? So I'll give you a concrete example instead of being abstract. So this is one example of some work we were doing recently with Los Angeles City Attorney's Office, and it was a similar problem to the Kansas example, where they have a team that's sort of in the city attorney's office. When somebody gets arrested for misdemeanors, they get booked, they go to court, and somebody from the city attorney's office has to show up and plead their case. And what they say is, look, we typically get an hour to get ready for this case, and we can't even connect all the data and look up all their history and all these. They have 3 different systems and 3 different computers, and so we don't have time to even figure out what's the right thing to do for this person. And often this person needs some social service program, some assistance program, but we can't even figure that out. So this person keeps cycling through the system. And so they asked us, is there a way you can tell us, for the coming month, here are the people we can prepare these case files and figure out programs for 150 people every month. Could you build a system for us that could identify the 150 most likely people to come back for arrested for misdemeanors, so we could pre-prepare their case files, figure out what program support they need, so when they show up, we can go in front of the judge and design that program for them. If they don't show up, nothing happens, right? So we sort of started building, that system. Again, all the data collected from different sources, different things, put it all together. And so the first version we built for them was sort of designed for efficiency, which means like off the 150 people we gave them, 73% of them were going to come back, ended up coming back for misdemeanor, arrested for misdemeanor. So it was 73% efficient, but it turns out it was more accurate for white people than Hispanic people. And when you look at the data, it turns out that the Hispanic recidivism rate was higher than white recidivism rate. So what ends up happening in this case is the system helps both people. So recidivism goes down for both groups, but because it's more accurate for white than Hispanic, the white recidivism rate goes down faster than the Hispanic recidivism rate. So it takes an already disparate system, because you're starting with different points, and it makes the disparities much worse. So then we designed option number 2, which was designed for equal accuracy, equal efficiency for both groups. It was overall less accurate, less efficient, right? It was 2% less efficient. But here's what it did. It because it was equally accurate for both, it brought down this equally. So it didn't increase disparities, but it also didn't decrease disparities. And so we designed option number 3, which is designing for equity, which cost about the same as equality, and pretty 2% is pretty minimal. And what that did was it was more accurate for Hispanics. We tuned it, and so what that does, it again helps both, reduces both, but reduces one faster than the other in order to get to equal recidivism rate. And so with this menu, we gave them sort of this menu and said, look, if you care about efficiency, it's gonna cost you this much, but it's gonna have this impact on increasing disparities. If you care about equality, option 2, it's more expensive, keeps the status quo. Option number 3 is the equitable outcomes, and it's the same cost. And they went with number 3. But the point here is really, have reasoning at the level of what are the goals you want to achieve with the system? What are the social goals? What are the policy goals? And then having all the technical, there was a lot of technical algorithms designed in the back, and doing all this work to kind of finding for equity and all that stuff. But on the front end, it's a menu that policymakers are looking at and deciding, where do I care about more, and making those informed decisions, as opposed to, I'm going to use accuracy and build the most efficient system, because that could have unintended. So all of these examples are sort of, are ways of sort of thinking about what are our values? How do we turn those values into, action, right? And there's all the data and machine learning, all the things in the middle, but basically we're going from, here are values. How do I take action based on those values to generate the impact that I want to have on the world, right? And the examples we're talking about kind of, are big examples, right? It's working with these organizations and changing criminal justice and traffic safety and policing. But, what can all of you do to kind of take your personal values and turn it into action and impact? So I'm going to give you kind of four ways that I think about that. that we can do that ourselves, right? First is in the top left case, right? Often a lot of us, when we're doing sort of data engineering and things, we're kind of living in this world where we get some data and we do things with data and we do some analysis and machine learning, and we're kind of detached from, well, how was this whole project scope? What was happening? What were the values the system needs to have? And then what are the actions somebody is taking from it, right? We're kind of in the middle, and somebody's decided things here and then somebody's using it to do something. But we can't be agnostic to the first and the last pieces, right? Because what we're doing has impact on the world. And so what I want everybody to do is to question those things. Think about, well, what values, and then what is it going to be used for two reasons. One is it sort of gives you more visibility, which means you can actually do the data and the analysis and the machine learning stuff much better, because you have a sense of what is it going to be used for. It's not a generic system, it's a very custom system. The second thing is that it allows you to sort of figure out, is this embedding the values that I care about? And if not, I should do something about it, right? So that's kind of the second piece. Is if you do see sort of questionable things happening in this pipeline, then say something, right? Because some of it may not be intentional. Like the example I gave on the Los Angeles, if still optimizing for accuracy, which a lot of people do, not because they're evil and they want to make things worse, but because that's kind of the standard thing to do. But now if you think about it, well, that's not the thing I want to do. So you might want to question, but how did we decide that we wanted to optimize for accuracy? And the most likely answer would be, oh, we didn't decide, we just kind of assumed. And so if you see sort of issues around, accountability and transparency issues and ethics issues coming up in the kinds of work you're doing, raise your hand, say something. And I think that's it's a really good way to have that impact, because a lot of those times it might just be unintentional. The third thing is, which a lot of you already probably do, is pretty much every example I gave for the every project, we're using open source code. Most of it is built in Python and PostgreSQL and a bunch of Python packages. And so, all of these organizations are using open source packages to do this work. And so contribute to open source, and all the contributions you make to open source code, that basically leads to other people being able to reuse, and that leads to action. So, and the last one is, volunteers. So I'm just giving you one example, which is recently called Solve for Good. We've got government agencies, nonprofits who are proposing. Oh, perfect. Sorry about that. Somebody in the internet didn't like what I was saying, so they probably cut down my network. But no. So I was just ending with we have a new platform we launched, Solve for Good, that connects volunteers, software engineers, data engineers, machine learning people, data science people, that can then help solve those problems. So if you want to go check it out, it's early, so be gentle, give us feedback, see. But there are other opportunities for volunteering. There's an organization called DataCon that you can, again, work with to connect you with opportunities where you can help these types of social good organizations. And again, that's another way to take kind of, here are the values I care about. I care about these issues. Can I help people take action and have an impact? Right? So basically, that's kind of all I had. I think we sort of, a lot of us working in this world today with data and AI and ML, we've got this opportunity to actually have an impact in the world. And it's a question, sort of, it's up to us how we use this opportunity, and that depends on sort of what our values are, what we want the world to look like. Happy to I know we don't have time for questions here, but my email address is here. Feel free to email me. Happy to have a conversation, answer any questions. Also, just put in the GitHub repo link for all the different projects. All the code there is open source. So if you want to take a look. But thank you very much for having me here. And yeah, thanks.